Okay, there are a few things you need to know about the periodic table and the significant features of that table that you might find. To begin with, let's remind ourselves the difference between the properties of metals and the properties of non-metals. Metals are generally shiny, soft, malleable, which means we can make them change their shape very easily. We can work them into new shapes. And they're good conductors of both heat and electricity. Non-metals, on the other hand, are basically the opposite of all of those things. They're not shiny, but they're dull. They're hard whenever they're solids. They're brittle, so instead of being able to work them into new shapes, if we try to change their shape, they shatter. And they're also insulators, which means that they don't conduct electricity and they don't conduct heat either. So the two things are sort of opposites of one another. Semi-metals sit in the middle. So they're a little bit shiny, but not as shiny as metals. They're a little bit hard, but they're not as hard as non-metals. They're not as malleable as metals, but they're not as brittle as non-metals. And they, most importantly, they conduct electricity a little bit. So they're not insulators, but they're not good conductors either. Those are the semi-metals. All right, periods and groups. Rows in the periodic table are called periods, and each new period represents the start of a new electron shell. Take a look at a periodic table as you watch this video, and you'll see that there are 7 rows in the modern table that includes elements up to 118 protons large, so that's protons in the nucleus. That means that at the moment, the largest atoms we know have 7 shells worth of electrons. If we discover any new, bigger elements, they'll have to go in an 8th row. Columns in the periodic table are called groups. And that's really what we're going to talk about for the most part, for the rest of this video anyway. There are 2 systems of naming the groups. The old system uses Roman numerals and skips the 10 groups in the middle. The new system of naming groups uses Arabic numerals. If you go to page, I think it's 175 of your diary, you'll find a periodic table written there, and it will use the new system of naming groups. All right, now we need to learn a few things about a few of the major groups. The first one that we need to learn is about the alkali metals. You'll find them in group 1 on the periodic table. Things that they have in common with each other: they all form +1 ions, so that means they all like to give away 1 electron when they're atoms to form ions that have a +1 charge. They are never found in pure forms in nature. They're way too reactive for that. They're so keen to get rid of their electron and form an ion that they do that in nature straight away. They did it billions and billions of years ago. And so whenever we find alkali metals in nature, we only ever find them mixed up in compounds with other elements. Alkali metals are sort of the perfect metal, if you appreciate what I mean by that. So they have very, very typical metal properties. They're very shiny, they're very soft, and they're excellent conductors. The next group are called the alkaline earth metals. They're in group 2. They all form +2 ions, so that they all like to give away 2 electrons. They're less reactive than group 1, but they're still not found in pure form in nature. They're way too reactive for that. They also have very typical metal properties, so shiny, malleable, soft, good conductors. Now, skipping over to the other side of the periodic table is we find a group called the halogens. The halogens are found in group 17, or in the the old Roman numeral numbering system, group VII. They all form -1 ions. They're also too reactive to be found in their pure form in nature, but they can be purified in the lab where they form diatomic molecules. And you see some examples there. So fluorine, chlorine, bromine, and iodine F2, Cl2, Br2, and I2. They have perfect non-metallic properties. Noble gases, also called the inert gases, and that's because we find them in group 18, and they therefore have full outer shells. That means that they won't like to form ions or bonds of any kind because they don't need to in order to fill up their outermost shell. That means that they're incredibly non-reactive, and they therefore will exist in pure form in nature as monatomic elements. We can find small amounts of all of them on Earth, but they, particularly helium, is much easier to find in space, where it's the second most abundant element in the universe. They are all gases, and they are all gases at all temperatures. Finally, the transition metals. Now, that's the 10 groups in the middle of the table, groups 3 to 12 in the new naming system. Now, transition metals, all bets are off here, and just about anything can happen. They form various ions, and this is a short list of transition metals that you'll just need to learn. So iron, for example, likes to form a +3 or also a +2 ion, depending on the situation. Nickel likes to form a +2 ion, and so on down the list. All of those are things that we'll write on the back of our chemistry cards, and you should just work on committing to memory. Transition metals are in many cases found in pure form in nature, but those are that on the, that should say left side, my apologies, those on the left-hand side, or those that are lower in the period, are more reactive than others and therefore harder to find in their pure form in nature.